So I open up now this discussion. Of course, here you can have all in the MOSFETs, or you can have all with the gallium nitride devices, and
or you can mix both, because the gallium nitride is not the best for synchronous rectification yet. At least I compared them and silicon, standard silicon. They have better RDS on for the price.
Yeah, that's for an output switch, but a gallium nitride switch can be used still for two primary side switches, and a diode can be used with a synchronous rectifier MOSFET at 50 kilohertz, yes. Because unfortunately there is no, in my understanding, there is no reason why the gallium nitride, which was currently being made at 60 volts and have like a 2-3 milliohm on resistance, why they couldn't be scaled down even better than MOSFET. If you reduce 60 volt voltage on a gallium nitride to 6 volts, you have 10 times lower voltage stresses, and since they don't have a built-in parasitic diode or whatever, reverse diode, they should be naturally scaling down on resistance. Unfortunately, they're not focusing on doing that, and although in my mind there is no reason why it shouldn't be done. Okay, what couldn't be done anyway. So this is just in conclusion. I will finish this by saying, now when I showed you what is needed to get the transformer implemented right in at least in two different configuration, and that is, one is my original chip converter, the other one is now the hybrid switching converter, all in the not requiring more than 50 kilohertz. And now you can trust me when I tell you that isolated version is around the corner. Not only that, even better, much smaller size of a transformer, and with the zero voltage switching on a primary, zero voltage switch secondary. And guess what? Output current with a zero ripple, even though in the past I generated the zero ripple, like these two converters in parallel, or a coupled inductor. Now I don't need even that. Single converter, you have zero ripple on the output, very little capacitance on the output, and it becomes true zero DC high voltage converter directly to DC voltage, wide operating range, no feedback, open loop, you name it, we got it. Okay, so my parting point is I intentionally provided these previous lectures over 2 hours to all those who attended my lecture. I intend to do the same. So if you attended my lecture here, all of you who attended it, not those who signed up. There were 70 people signed up. So far, I see that 22 people participated. And those who participated, they will get this 2-hour lecture split into convenient to half an hour or so lectures. And it is made public, and I want you to share it with all your colleagues to spread the word that this is what is coming. And this is how you are going to learn power electronics. And if I shared so much knowledge in my last lecture of 2 hours, which I'm sure you had now ability to review all those previous ones, and in the present today's lecture of 2 hours, I also shared a lot of new information, which I'm sure is first time you have seen it and first time you have been correctly explained. So hopefully you can carry the word to your friends, your colleagues, your bosses, and others that my upcoming course is 40 times 80 lectures, 40 times 2-hour lectures like this. So if you don't find that this is worth your, like that I shared with you, that fellow from Pakistan who wanted to get, India who wanted to get discount of whatever. If you are working at a company and you don't want to invest yourself, and even worse, if the company doesn't want to invest this my small fee to learn the power electronics and have access to tremendous amount of material, I'm out of it. You are left in your own Coursera, Udemy, and other courses. And go to universities when you get 4 years of lectures at $60,000 per year tuition, okay, or support. So with all of that, feel free to contact me. I think you have my preferred email is my nickname, boran@teslaco.com. I have old, that works also. The old email is my last name, chuk@teslaco.com. But there I get 120,000 or 150,000 email collected. So I'm trying to, it's hard to find any new emails among all this. A lot of spam mail gets through. But my new one, boran@teslaco, is one to use. And as I said, feel free to share already these webinar 2 recordings, and share webinar 3 recordings, and join the course. You have 2 more weeks to do that, because as I said, I'm not sure going to do any more of this course unless I see that I have a good following. And so it's up to you to spread the word and get your friends on it. And the other thing is, I now decided also to make attractive, find two of your colleagues, whether your boss is going to pay for you and 2 colleagues, or you and 2 your colleagues pay for it, then I reduce the price to $400 for 6 weeks of education and access to tremendous amount of teaching material, course notes, and everything else. And you get for free, not for free, but you get at the top of that, you get my explanation, and you get direct access to it. And I'm now open, since you're a relatively small audience which stay through it. Feel free. Now I see, except for me and Krzysztof, you all guys are with muted microphone and muted video. So I'll turn it down now to gallery view, and feel free to, I see it, to join asking question by audio and video. Also, I think we have ability all along, just for a future, that while I'm talking, presenting it, I gave you opportunity to do that, but you have all along opportunity, like all of these, to ask the question in the chat. So next time when we have that, feel free to type a question while I'm talking, so that way without interruption I can address the question by looking at your question, which sometimes might be useful to, because the question may be posed which might be, I say, useful to explain to everybody, and without interrupting me, I can read that question. And also at the end of the whole course, I can really, provide a separate answer, because all the chat questions are also being recorded in addition to this presentation, okay? So here it is.
Professor, can I ask one question?
Can you what?
Can I ask one question regarding your CHUK 2 converter?
Yes.
We saw that the output voltage of this converter depends on the duty cycle. It depends on the turn ratio, and also on the input voltage, VG on the input. For example, if input voltage suddenly change, or for some reason, or if there is a load change, how do you regulate the output voltage without feedback?
Okay. This question has Very simple answer. I claim, and I've done that 30 years ago, 40 years ago, input voltage regulation is the best handled in a pulse width modulated converter, which this one is. This looks like and smells like a resonance, but it is pulse width modulated. You see, it's a duty ratio modulated. And if I change a sudden change of output input voltage from, say, 12 volts to 24 volts or 24 volts to 12 volts, I can make my ramp, the sawtooth ramp, I can make it directly controlled by the input voltage. So what happened? A ramp is controlled analog-wise by input voltage. So I don't care what input voltage does. In a single cycle, so-called feed-forward, no feedback, no stability problem, I will regulate the output voltage. That's number one. Number two, regulating with respect to current is this. If I have a sudden change of a load current, in the good old days, or as I should say in the bad old days, when the efficiency is 80%, that would be a problem. Even if I had no change of mode of operation from no load to full load, at 80% efficiency, I will have to compensate from no load to full load because I will have to change the duty ratio to compensate for to change the duty ratio for that much. However, put yourself in a point where this converter now can operate at 99% or higher efficiency. The point is that 99% of higher efficiency, what that means that there is a 0.5% at maximum change of output voltage due to change from no load to full load. So that means really you don't need even to change the duty ratio because you will have such a minute change, 2% change in your output voltage, 0.5% change in your output voltage. But even if you want to be precise, there is no reason why you couldn't, have an open loop, have the same ramp, which is being controlled by the input voltage to compensate in a single cycle input voltage, but the same ramp can be affected by sensing what is the actual load current and knowing in some kind of a lookup table to say, oh, for 100% current, I want a duty ratio to be 0.11. And then for 50%, I want to be 0.105. You know what I'm saying? So you have a fancy digital control, but not really digital control, but either analog control with the ramp by sensing the current, or you can have a digital control lookup table and say, whatever you sense the current, this is now duty ratio, you have to give it. And then the story. Here it is actually output of two converters in parallel. And
it's running open loop, and there is like the duty cycle is constant, and there is a step load, 2 ramps, like there is base of 10 amps, and then there is a ramp and another ramp. So it's just changing the output current. The load is changing, but the duty cycle is the same in this simulation. And that's the output voltage on the bottom, green. And the current is in the middle. And on the top, there is the average current is on the top. So the output current is following the load and without even changing the duty cycle.
Yeah, okay, I think we had the simulation done step load change, but neither Plex nor I think Simplest is probably more suitable to do step load change on a single converter, because the Simplest does operate with on a single does operate with steady state conditions, whereas plexim requires to go through a number of cycles to settle down, even though I modified it. So my plex simulation is such that actually doesn't go through thousands of calculations or thousand cycles, because it actually gives an optimum initial condition that only have a 2 or 3 transient, 2 or 3 cycles before it settles to the final. But still, you have to go through the change of. So the best proof would be really make a hardware demonstration, because it can be easily done. You have a switch and you change from 1 DC current 100% to 10%, and then measure the transient. So that'll be, I say, direct proof. But it's a little bit more difficult to do it now, because none of these simulation programs are really well made to take care of the sudden transient and do it right. So I think I would have to reserve the result to make sure that it's verified with the actual experiments. But in the meantime, it is obvious when I do you can see it when you simulate a single converter, when you change the current from 100% to 10%, you will see immediate change of the peak of currents and so on, because the converter is driven by the load current, and load current imposes the resonances, imposes what next cycle is going to demand from a converter. It's not fixed converter with the voltage to voltage like a buck, and then you have a 12 buck converters in parallel phase shifted to really, make a concoction which will hopefully help you with the transient, but still requires a megahertz for each switching converter, 12 of them in parallel, and still, you get a lot of switch capacitors, chip capacitors to delay it in big state. I don't understand how the present industry with the Intel, AMD, Broadcom, the Qualcomm, what I said, who else is Apple? They all have a TSMC. They all make a microprocessor which require tremendous transient requirements, and they still use this 12 buck converters at 2 megahertz. So it beats me, but it's their problem, not mine. Hopefully soon they will realize that it is even bigger problem with my new chip 2 converters, isolated and non-isolated. Okay, and as I said, thank you very much for attending this. Feel free to send me any questions and comments. And as I always conclude my presentation, if you like my presentation, tell a friend. And if you didn't, just keep quiet. So don't spread the word. But if it is something that I really hope that all power electronics field will realize that we are in a dead end, and we have to really now change the way that is being done, and change the way of publications, change the way of conferences, and it looks like it didn't change much. I think the conferences are now charging just as much, not offering anything, and not even having the cost of providing those facilities. That's all free, online, right? So, and online, now it makes it, there is proliferation of the papers. It doesn't cost them anything, right? They don't have to publish the 500 pages proceedings. They can publish 5,000 pages proceedings because it's all stored in a cloud, right? So we are in a big trouble. I'll tell you, I'm not optimistic about future, but I'm going to do my share to hopefully generate the following and generate the people to listen to what I'm doing and help implement some of this. Okay. All right. So, any more questions? I'm still on. Let me put it on the gallery view. I think any. Andre, where are you? Haven't seen you like last time. You contributed a lot of discussions. Hello, Fernando. Any comments, any questions, any answers that you want to share with the people?
as you can see, I allow myself to raise a question concerning simulation tools. We have been speaking quite a lot about the quality of
What did you say?
I raised a question concerning simulation tools.
Okay.
It was what today you mentioned a few times that simulation tools are either bad or good, and I would be interested to get a kind of comparison between available commercial tools and to know a bit more about what is your experience with the different commercial tools and what would be your recommendation.
One thing I put it on a speakerphone, and when you are talking, I was expecting that you will get speaker view the whole screen, but it didn't happen. I don't know if this is part of the control that you need to do or what is it? Okay. Oh yeah. Okay, I see it now. Go ahead. Yeah, when I see you in a big screen, I also, when you talk, I can better follow what you're saying. Okay. So you said something about a Plex simulation that
not only about Plex simulation. My question was about simulation tools in general. What kind of recommendations you could provide us concerning available simulation?
I think let me give you a general answer to that. All simulation tools have a wrong premise. And I know that because when I was back in Belgrade in electrical engineering, I worked in minimizing function with so many variables and so many constraints, equality, non-equality. That was my actually diploma work. Then I realized how this whole system works. They generate objective function, which is error function, and they want to minimize the error. The problem is when you do that, and there is a Newton-Raphson and many other programs how to do that. The problem is all these programs depend on, they don't come up with a minimum, absolute minimum. There is no absolute minimum. They end up in a bunch of the local minimums. There is no way, so the only way you can do in a simulation is start with it's two problems. You start with arbitrary initial conditions. And then depending where you start, it can drive you in, local minimum, which is really not a real solution, which is one of the bad local. So what they suggest when you get the wrong result, well, try with a different initial condition and hope for a best. No, you may end up in a different final result. Even worse, I've seen it even with the Plex. I make a simulation with my converter and I put in it magnetized inductance of so many microhenries. I get a convergent solution and I get a correct solution. And you know what's worse is I change it 20% magnetizing inductance and now it doesn't converge. It shows you why the system is bad. And what is a bad, not only with the Plex, with every other system, SPICE in particular and others, which I'll explain you why, they all start with the arbitrary initial condition. With the Plex, if you have a system with the 3 inductors, 3 capacitors, you have an initial condition with the 6 variables. Each 6 variables, it can be given to 5 different values. It is so many different conditions. And you know what? It starts with the arbitrary condition, which has nothing to do what is the final result. Why I'm saying that? Because it may involve the millions of calculation. And if you and it records all of this calculation as you move along. And if you record all of this calculation, what is going to happen? You have a finite word of computer, and each time you make calculation, you make a little error. Then there's an accumulation of errors, and that's why you end up with a dead end. You end up with the wrong result, or you end up with the no convergence, right? That's a big problem. Now, how I solve that problem? Let me explain it. I solve that problem just like you heard about Amazon is going to deliver packages, not anymore which I get at home, directly to my home, but Amazon, if you get a package to deliver, it's not going to be a truck goes through all these streets and so on until come to my house. It's going to have a drone, and the drone says, go to my address and just drop directly to my address when it needs to be. Okay, I'm just comparing that to how at one point, Apple tried to make a map, right? And emulate what already Android people were doing and Google and so on. And their first map things ended up, you give it to some city in the East Coast and someplace in the middle of the Pacific Ocean, right? Because it wasn't done well. But what I'm trying to say now, when you have this kind of what I provided to the field, and that's what I do in my first lectures when I talk about it, I introduced this what's called the state space averaging, the method that works not only for PWM converters, but for this type of resonant converters which I introduced, but I never published a paper on it. What it does is I use my state space averaging in two ways. I use it analytically, and for a simple converter like this, I can determine on a piece of paper using my state space averaging, as you saw here, what is going to be DC voltage on all the capacitors and what for given duty ratio, and what is going to be DC current, if anything, on inductances. And I gave this steady state conditions as initial condition. So I eliminated millions of calculations, and I need only 3 or 4 switching cycles to determine the final solution. So I'm starting already so close to the final solution and just need the details of the time variation, because I don't want, as you could see here, I could even, for this converter, I could even derive analytical expressions and to tell you what the current is. Or some other, resonance may be attenuated, not a clear sine wave without attenuation. I would need a simulation program to do it. But the point is, I reduce it from million calculation to the 10 cycles, last 10 cycles. And therefore, I don't run into problem of the convergence, don't run into problem of accuracy, because if it is so close to final solution, there is no way it's going to end up in some wrong steady state or in the wrong result, okay? And I can't explain them for years. All of this program will be helped, even SPICE and so on. But I know the people that the SPICE is patently wrong for this. You don't need a SPICE program which will calculate when you have a square wave current or square wave voltages and you have a slope, that you're just going to calculate so many during the transition. They'll have to calculate to get the right transition, divided in 100. So they have to make many more calculations. I don't need that. I don't need a model for a switch. What they do in this analog circuits for a IC circuit design, I don't need a model of a switch which has 20 different parameters. The only parameters I care why I use the plex is you put a on resistance of a switch when the switch is on. That's all. I don't even put a parasitic capacitance drain to source. I put a separate capacitance on it because that's actually when I design a zero voltage switching, I don't want to depend on a parasitic capacitance of device. I want to overpower it with the picofarads or nanofarads of a capacitor I put across it, such that I dictate the resonance and don't depend on one run of the production, which will produce 5 times different parasitic capacitance and so on. So basically, my simulation is ideal switch, resonant capacitance when it is on switch, and then put any external capacitance I want to control the resonance, we can control them. So as I said, getting back to this example of a drone, if I compare it, analogy, how everybody uses not only Plex program, but everybody uses another program, it is like you're giving taxi driver in New York to drive to my house in here in Laguna Niguel, and then he starts in New York and goes this street, that street, another city, another. So he has to go through how many steps to get to here. Whereas I compare it with the drone, when my state space averaging is like a drone, giving a direction. Oh, you're in New York. Come to my house at the gated guard community and land right there, and you have 5 houses down the road to get to my house. End of story. You see what I'm saying? And then I eliminated all simulation. And I'll tell you one thing. I'm developing such a good, feedback from using that program that it is a great tool. Nobody else using it, like I'm using it, because I don't run into problem and doubt but the program will give me a right solution. I know it gives me right solution and correct waveforms. And why it is useful as my research tool, I'm looking at some new converter structures and new magnetic structures. And of course, even I have a way to make magnetics models or through reluctance. But the point is, I cook up with some new idea and I want to verify it. And what does it take me? I don't need like I used to have my 3 engineers and working for 3 weeks to build a prototype, and then I wanted 5 different inductors on 2 different capacitors to test. I don't need it. I do it in 1 hour, myself. And when I get the result, I can see whether it's what I want to get or it is off, and then I can find out what's the problem. Maybe as I said, my transformer, I thought it does have a no DC bias, but it turned out, yeah, there is a reason why I did have, in the particular converter, needs some small DC bias and so on. So basically, I use that to get to quick to results and quick to solve the problem. And not only that, now I used to write all my patents, and I would have verified it myself on a bench with my engineers helping build the prototype and changes and so on. I don't need that because that's not a real proof. Because the real proof is now I proof, and I said, look, I simulated in this program and these element values that I use. I don't depend on a type of switch, what is available, what is capable now, what will be capable in 5 years from now. I use it. Say, hey, if you get a switch with this characteristic, with its own resistance, and you have, I put a parasitic capacitances or whatever on a drain to source to simulate it, this is what you're going to get. And I can even tell you, you don't have to build a prototype. You can go and use my simulation result and build it directly on a PCB, and it's going to work exactly what my simulation showed. Because I have that much, but of course I had that because now I believe in my results, because I know how I'm developing and I'm based on a system which really shortcuts all the disadvantages of going into, non-converging, going into wrong local minimum and all of this stuff. So that is a, great tool. And of course for me, I have a confidence that I proved it. I don't want to submit any patents or any application where I don't know this is what is going to work, but no need to tie myself to particular switch, particular device. I just disclose what is my assumption, and anybody can repeat it that way. The key is that gives me tool, because when you have a PWM converters, you had a ripple voltages are triangular, ripple currents are triangular, and nothing to do it. And I could do that. But now with the resonance that I have, you see there are resonances which have 100 amps DC and 200 amps peak-to-peak sun wave. So it's not easy to see, even though I'm trying, and I did in this case succeeded, to predict analytically what the waveforms are going to be, because they ended up beautiful sine wave. But there may be some other cases that there will be a little bit different and so on. So it's useful to have a powerful computer doing it. But as I said, always I said, artificial intelligence versus natural intelligence. I dabble on the side in playing the chess, and I looked at the Alpha Zero beating everybody in the chess games and so on. But I feel I would give a challenge to the this 1520 team who made Alpha Zero to play Go and to play chess. I will have a challenge and say, okay, Alpha Zero, go design me the best converter in the world. I don't think Alpha Zero will be able to do that. And I think I can beat Alpha Zero anytime in this objective, okay? Because it takes a lot of understanding in theory in this field to really understand what you need to do. And I don't think you can teach the computer. On the other hand, if I use a computer like for simulation, and if I use a computer to play chess, I can tell you if even with the second hand, like Stockfish playing with that, me playing with him against Alpha Zero, I could beat it, you know, because human being with the help of tools like computer program can always beat a computer program, because the computer program is still made by people which have their original mistakes and problems and issues. Okay. Anyway, this is a side comment. Thanks very much for your question on that. But I think there is a lot that need to be done to improve all this. There's so many different simulation programs, but I don't think none of them is really fitting the bill. And hopefully, you know, I will have, you know, the some impact if some of these companies who are making simulation programs want to really improve. I could help them, you know, but it's up to them. You know, they pretty much have a little bit, I say a little bit arrogant, and they feel they are too smart and they don't need anybody's help. But that's my feel so far. Okay. Okay. Let me see. Let me put that on the gallery view. Anybody else? Fernando, thanks for a question. Tomasz, you are from Czechoslovakia, right? Yes? No?
Not exactly. I'm living in Northern Ireland, but originally from Poland.
Oh, from Poland. Sorry. Hey, Krzysztof, you should have warned me that Tomasz is not just a Czech name, it's also Polish, right?
Yes, I know.
Is Tomasz a Czech name or Polish?
It is both, but it is written differently with accent in the Czech language, but Z at the end in Polish.
Oh, I see. So you guys could distinguish from how it is written, where it's a Tomasz in Czech or Tomasz in Polish, right?
Oh, it is like your last name is from Serbia, and we can distinguish this.
Oh, yeah, that's right. Yeah, but my last name is Serbian, but it's not typical. Serbians are just Russian. Popovic, Petrovic with a hard ch. That's Serbian. Petrovic means the son of Peter, like Peterson in Swedish. But my name, Chuk, is very unusual. You know why Tesla has such an unusual name? Because Tesla is born in a part of Croatia where Serbians live. And my parents are also from that part of Croatia called Lika. And people had their last names given according to the, how you say, traits. Tesla is a carpenter tool to work on tables and so on. Chuk is a translation of the Chuk is in Serbian means either way, both translation you can find it. It's either called the night owl or it's called the little owl. And that is from a family of owls. An owl is a big thing. I have at home, you know, a bunch of the versions of it, but the big thing with the big eyes, big ears, and it says, and
yeah, and it flies silently.
Chuk is a 20% small version. Looks like it has also big eyes, but it says chuk, chuk, chuk. So that's okay. Sounds like this, and it's called Little Owl. And I have my nephew that he's here. He used to play basketball for some top teams. He's 2 meters and 10 centimeters, you know, tall guy. And I call him a big Chuk, and I'm Little Chuk. And when they call me in high school, they call me a Little Chuk, because when I was studying first year of high school, I was shortest on next to the shortest on the bottom. And by the time of the fourth grade, I became second from the top, okay? Like 181 centimeters. I did play mainly basketball some, but really I was much better in soccer, okay? Because I was not tall enough for a basketball. But anyway, and Slobodan, that's a very famous Serbian name and means free. And same thing, the Polish and Czech, Svoboda means sloboda. Sloboda means freedom, and Svoboda in Czech, and Svoboda, is it in Polish the same thing? Svoboda?
Svoboda.
Yeah, Svoboda means freedom. And the reason is I was born after Second World War and baby boom generation, and every second boy was named Slobodan, and every second girl was named Slobodanka because of that. And why? We had 1.8 million people killed in the Second World War out of 15 million population. We are probably second largest casualty in Second World War after Russia. Of course, Russia is way out. 45 million were killed, and out of, I don't know, 150 million, 25%. But we had 300,000 killed in battle, partisan techniques, against Germans and Italians, but 1.8 million were casualty of the fighting, and some of that were also the, concentration camps, which were, a big one, there was 800,000. Yeah, the biggest one out of 1.8 million, 800,000 was killed by Worcestershire concentration camp in Jasenovac. And that is the biggest crime ever, because even Germans who did so much with their concentration camps in the Second World War, some of their generals couldn't understand that in Jasenovac they put a lot of families and kids with a few years old till 12, 15 years old were killed in this, and women. And Germans didn't usually do that, but anyway, this was the atrocities of war. Hopefully it would never repeat again, but you never know. World is getting crazy. I don't think that I rule anything out. Everything is possible. But anyway. Okay. Any more technical question? Because we can always go to this war stories, never end up what's happening. But I am worried, my concluding thing is I'm worried that the world is becoming very much divided, and the technology is not really driving the future. It's politicians and division among nations which is driving the future. And this is unfortunate, because I believe firmly that what we can do now, it's what Tesla couldn't even have dreamed about. And that is, he had his alternating current developed in 15 years, from 1882, when he invented rotating magnetic field and induction motor, synchronous generator. By 1895, he was lighting up Chicago fairs, introducing. By 1900, there was alternating system transferring the power throughout the world using his AC high voltage. And even then, people didn't realize, do you know that there's a huge, I talk about this transformer, but really, he needed the generators. He needed the Niagara Falls to generate the megawatts power. But how was megawatt power transferred to Los Angeles? In the blink of an eye. Why? Because of that transformer not storing energy. You understand? And high voltage was a high voltage and 200, 400,000 volts and milliamps of a current. And what that means is these electrons, which are free electrons in a copper wire, this is not that electron which needed to come from Niagara Falls to Los Angeles. This electron only traveled a little distance, which was whatever it took free electron to travel to accelerate, and then it hit the nucleus and lose power, in this instant. That's a copper loss. That's a loss in the conductor. but the transmission of the power happens not that with the electron, he got stuck, on the first nucleus, but many other electrons carried with the speed of light, which Maxwell predicted that is what is going to be transferred. And then that's why we don't need to wait. Now there is a big difference. We don't need any more, gas or any more coal, any more oil to produce generating power. We have it free out here in California every day. When I get up in the morning, if it is clouds, I'm not ready. I'm not really excited to get up. I want a clear sky. So you have electricity. You know what's a solar power? It's a 1 kilowatt per square meter. 1 kilowatt per square meter is a solar power. How many megawatts and gigawatts of power is available and wasted every day that we are not converting it? And it is free, and it is what is really needed now, and that's why I'm spending the time. What is needed now is, for the first time, we can use a transformer, but inside the DC to DC converter, converted to the high voltage DC, 100,000 volts or more, and then step it down on the other end with using much easier. Then you can, right now, they talk about solid state transformer. You know what they do? They hide behind that. Solid state transformer is like a big thing now. Everybody has this solid state transformer. But what they do, they have high voltage AC. They convert to rectifying it with whatever method they have to convert to high voltage DC. And then use just conductors of high voltage DC current so they can put it underwater, and then go to island in Britain and then use this opposite DC to AC conversion from high voltage down to high voltage AC. But this is 3 converters: AC to DC, high voltage, DC piece of wires under cable, and then on the other end use a complicated converter which is also DC to high voltage to high voltage AC, and then transmit the high voltage AC. There is no need for that. And as I explained today, we have now ability in DC to DC converters to regulate, okay, and to operate without, feedback, without automatically with a high efficiency. And use what? Use the solar power as the source of the power. Give an example. When I was making many years ago our first 4 kilowatt photovoltaic inversion, I looked into it. At that time, efficiency was solar cells were 10%. Now you can make a gallium nitride cells and others which have 40% efficiency, which means of a kilowatt power, you get 600 watts delivered in a meter by square meter. And if you are here in California desert, in a Death Valley, all you need is 100 kilometers by 100 kilometers area, which is desert, and nobody wants to live there. Even some of these animals don't appreciate it. Then you cover it with the solar cells, and it's 100 by 100 miles. Say 100 by 100 miles. You have enough power to provide for the whole United States, not only for residential but for industry. Okay, so that's the future. And once we have this much energy available, can you imagine what we can do? How we can build the roads, how we can build anything, right? Because we don't have to work with our muscles. We have automated robots and everything else works for us. So I see the great future, but the only problem is that I think the industry is unfortunately conservative as much. Now I can see much more resistance that I faced with my work for the last 15, 20 years than in some way Tesla was lucky, because in 15 years he was able to put his tremendous effort to electrify the whole world. And now, you have all these companies and just fighting tooth and nail not to accept anything. Why? Because they have to pay 1% royalty for your inventions, okay? How stupid is that? Okay, but that's how the work works nowadays. And unfortunately, until these big companies start losing big time and not being able to, because biggest problem of these companies is not pandemic. This has come and will go. And as some people say, this is something like a Spanish flu. We'll get it over by end of this year, and then in 100 years there will be another pandemic like this. But the biggest pandemic is the people themselves. They just don't really, they are not open to innovation, which would dramatically improve the life for everybody. And unfortunately, that's in a human nature, I think. They'd rather fight the wars and take away from other countries rather than working together to join in a future world. So, okay, and that's how it is. Okay, let me ask Robert, are you recording all of this? No, he's not there. I think he's putting it on. I have this also recorded by special team, so that's why your video was such a nice. Believe me, it's not automatically done that way, but there's some effort behind that. Okay, and all right. So, okay, thanks a million. And as I said, May 3rd, get your friends to join, and then I will start writing this, my textbook, actually making this presentation, because what I did many years ago, a lot of that is now subject to be revised, and provided a really new way of looking into power conversion and power electronics. But unfortunately, there is so much resistance, and as I said, proportionally, so many publications, so many companies, so many universities, but unfortunately, the output is not nearly proportional to that. Just like our product converters operating at 1,000 times higher frequencies are 2 times smaller. So that's a built-in problem. And anybody I see here from anybody coming from Europe? In addition, Thomas, you are in Ireland. Where are you? You said you're in Ireland, Thomas?
Yes, I live in Northern Ireland near Belfast.
Oh, Northern Ireland. Okay, so
it's quite quiet now. It was not very famous decades ago, but I'm only 14 years here.
What is it? Not? Oh, I see.
There were times of troubles, IRA and.
Northern Ireland, but now there may be even more trouble with this. You may separate and join the European Union, right?
So not so bad, but one good thing about Northern Ireland is actually then it's plenty of skilled people and new businesses coming to play. So also involved in some projects for Republic of Ireland. So just now I'm operating very well.
Okay, so how are you doing with the pandemic? Are you vaccinated all, or are you about to, or what?
Not yet, not all, because that's obviously a very cautious approach. So
is at the top of vaccination in Europe, right? Whereas France and Germany are way behind, right?
Yes. We say that should be done by drivers of Amazon. Everyone would be vaccinated next day.
Okay, so call me, send me email with any of the ideas you may have that might enhance my presentation. But as I said, I will put my effort now to revise the how the power electronics is being taught, and hopefully there will be textbook coming out of it. And then after that, I am going to focus exclusively on my present work, which is really exciting, and I'm accelerating. Hopefully, power electronics will learn about it in a year or two, what is happening and what I'm creating now. And,
yes, I think that the power electronics is important with renewables, and it's happened that I had a project for the company helping to reduce the losses in the grid by turning on the heaters for the hot water, for example, or heat pump whenever there's excess electricity in the network. So there's lots of interest and actually billions to save on unused power when you may have too much electricity at night in Ireland when the wind is blowing, or over the weekends when the sun is shining in some countries. Yeah, yep. So definitely, I see the big area to actually have very energy efficient converters.
Yeah, but one thing is also you probably heard recently in Texas, Texas has an unusual thing. United States electricity grid is divided in northern and southern, and Texas, for some reason, had the independent grid and didn't want to be part of the United States grid. And then they didn't count that they're going to have a cold spell. And when this cold spell, they stayed without electricity for 4 days. Hundreds of people were killed. Kids were, in sleep, died from no heat. They had a fire hydrant which were frozen, and they couldn't use it to put out the fire. So it was horrible. But that put the emphasis how much Tesla alternating current system was important for livelihood of the people throughout the world. You lost the power, you lose a life. So that's.
But the technology actually shifts in unexpected directions. Now we have so good control that bigger part of the losses in a grid is actually considered to be skin effect. So it is why Chinese, for example, put a very long line to Tibet on DC, just to reduce the losses. It is why the underwater cables are also on DC, just to reduce the losses, because the cable is much smaller cross section when it can be DC. So
it's well known that not only that help distribute the power underwater, but conduction losses, there is no interference even at 60 hertz extra AC losses. So the conduction losses in DC are much smaller. But the more to the point is this: the alternating current requires generators, require the gas turbines, generators, coal, and all other sources which cannot be turned on and off instantaneously. But with a DC transmission, not just DC high voltage as a transmission and using connection with the AC high voltage and on one end rectifying and on the other end increasing it. But in native DC can be directly tied to the solar power. And then if you have a distribution line, you have also solar power, say over 12 time zones and spread. And basically that solar power is providing automatically the whole grid is powered at all times, and it provides balancing. In other words, it's very easy not just to disconnect the solar cells and not produce the power if you don't need it, not waste it. You know what I'm saying? Yes. So that and plus it is free. The only thing what you need to do is maybe have robots which are going to wash the panels, because you don't want to have a dirt on the panels and you don't become effective. So that's basically the only thing you need. Once you set it up, and solar cells could last hundreds of years, so it's not, so I see the bright future, but we need to put a little bit more push in the next 10, 20 years. I hope I'll be part of it, to make a native DC transmission lines, high voltage, but pumped by the solar cells at few volts, but a bunch of them in parallel, and also stepping down for high voltage DC down to a couple of hundred volts and 100 volts, because the only thing which they don't have is a native DC motor, but everything else operates on DC, right? So that's eventually, hopefully, one day we can make even DC motor operate. Well, there is DC motor, but it's not effective as AC motor. But anyway, that's, no, I see the bright future for power electronics, especially the young kids who are getting into the field. There is a lot of challenges and a lot of already provided solutions, which I hope they will embrace and help develop it. That's the thing.
Thanks for the word for the weekend.
Okay, look, one last question is, last time I set up a course on Monday, and then this webinar, and the people said they couldn't make it because they had to work, some of them. So that's why this time I set it up on Saturday. So it's hopefully nobody interfere with anybody's, the work schedule. So in the meantime, the guys, are you picking up the work now? So it's not more like you're staying at home doing nothing, but actually the company is giving you homework, right? What's happening in Sarajevo, Srđane? I was born in Zagreb, but then when I was 5 years old, I started the first grade in Sarajevo, Miljacka. And I lived in, I don't know if it is still there, but I lived in the center of the Sarajevo, where there was a fiskulturni dom across, and next to that was the gymnasium, which had a basketball court. And fiskulturni dom had all these volleyball games and between the teams, and Miljacka was right next. And there is a big boulevard in parallel with river, and I was in downtown. Lived there at 6 years old, and then moved to Kragujevac, and then from Kragujevac to Belgrade. Actually, before I lived Kragujevac, then to Sarajevo, and then from Sarajevo to Belgrade. So I started first grade in Sarajevo and continued a couple of months later in Belgrade. And ever since I was there. And when I was 25 years old, I left to United States. Good old days. We don't hear you. You don't have a. You don't.
Now it is okay. Now it is okay. I couldn't unmute myself. Now it's okay. Sarajevo, unfortunately, I think that it is not so changed. Maybe when you were in Sarajevo, I think the changes are very slow in Sarajevo, because unfortunately we had that war in the beginning of 1990s. So that civil war really stopped our development, unfortunately. But these days, I think that maybe the things will get better.
You know what? This reminded me, when I was in high school, I had a teacher who was like a physical education, and he liked to take us for a skiing. So one winter we went to Han Pjesak. You know Han Pjesak?
Yes.
We went to Han Pjesak, and I remember from Sarajevo, we took a train, which is called the Chira, and it was going uphill. It was going so slow, so you could basically take off of one wagon and go drink the water and pick up the train and go back on the same train, So.
Unfortunately, that trains are still the same, and nothing really improved. So unfortunately, we do not have trains anymore.
Yeah, but one thing that did improve, you had this Winter Olympic Games, so I'm sure a lot of places to stay there were built and still operational, right?
Yes, for example, our two mountains, Jahorina, which is, and Bjelašnica, which are main mountains in Bosnia and Herzegovina generally, and one of the main also on Balkan mountains, they have very, very, very good tourism. In last year, so this year was very good for tourism, for winter tourism. The snow still on Jahorina and Bjelaštica, the snow is still falling. So due to this pandemic now, skiing is closed in March. But I think if there was not Corona pandemic, I think that people will be still skiing on the Jahorina and Bjelaštica. So maybe, as you said, these things, this ski tourism is really, really, really good in Bosnia and Sarajevo in general.
Very good. Nice to meet you guys from all over the world. Anybody who is the furthest away from California, you guys in Europe are 9 hours. I didn't see today I missed Nathan Vinera, who is from New Zealand. And that's the farthest away that I could reach with my courses.
But I just want to add something. If there is anything positive about this Corona pandemic, is this online process, which allows us to see each other and to have opportunity to be on your lectures.
100% agree. And I hope that exactly, I can't agree more with you. I think to me, I felt my reach was very much limited. I had a room at the beautiful lecture room in UC Irvine. 150 people could see it. Fantastic lecture. You can see it from my website and so on. But nothing like being able to reach the large audience and have this whole audience participate in that. That's what I did like last class, webinar 2. A lot of people then asked questions about patents and this and that. And I think it was a good forum to exchange and to and the whole world is now a small world. It is now a truly small world, and I am really encouraged, and I hope that this will grow, because now with my experience of 50 years plus in power electronics, I can reach the whole world. Literally, I can reach the whole world. The only limitation is I think it's a little bit hard to reach Japan and some Iran and things like that. But if this pandemic is over, I might even do a course in Belgrade, which is 9 hours from now, and then doing one course from United States and one course in California and one course from Belgrade. I could literally cover the whole world. I mean, literally one half and then the other half. So that's a tremendous way that the knowledge can be shared, and I think that's really fantastic. And I see that in the future, not only that, that'll tremendously accelerate the knowledge. You know why? Because in United States, not so much in Yugoslavia, former or all countries there, we had a free education basically at the time. But here, the education is very expensive. I got my daughters at Princeton when she was 20 years ago, when she was an electrical engineer studying in Princeton. I paid like $35,000 room and board. Now it's like $70,000 to $90,000 a year. I mean, and that is if you have $100,000 salary, and it's not tax deductible, how do you support the 3 kids? I had 3 daughters, So you have to be either extremely rich or one way or another to support education. Now, I think it's becoming more important now in this kind of environment that I always said it's not important anymore which school you went, Harvard, Stanford, Princeton, Caltech, when I went Berkeley. It's important who your teacher is, because this is when you're going to learn from. If the guy really knows a lot, you're going to learn a lot. And you can have a Harvard and a fancy school and pay a lot, and you may not learn nearly as much. So this is now kind of making a level playing field that hopefully we will eliminate all these self-appointed teachers, because the market will determine who are the guys who can deliver, and who you want to go to, and the price is much. I'll give you an example. I was charging this course $2,500 for a 4-day course, and then eventually was going to charge 5 days, $3,000 at the time. I had 340 people, had to pay the big lecture rooms, recording, and all that. But nowadays, when this was available, I said, look, I can afford to reduce the price 10 times, because if I get 10 times more people, the only problem is to get the people to understand this is a price. It's not, how you say, whatever I call it, this Coursera and other courses, when the professor records some course 10 years ago, and then it becomes replayed all the time for free. You need to have live person to interact, to explain you what you're thinking is wrong, to answer the question where you have a lot of material to study. And when you read it, then you can come back with the questions. The whole point is interaction, question, because I've been there, I've done that, I've been there, and I can give you answer and directions how to study and how to read material which I've uploaded there. So, and one thing I always love, this here, this is my, you won't believe it. I was teaching this way with my pen, 30 years ago at Caltech. I bought, at that time, they didn't have a computer. You can see what you are drawing, like I can do now. You had a computer which had X and Y wires, and I could draw it, but you couldn't see anything. And then it was connected to monitor, and monitor is actually projector. So I was actually drawing and looking at that projector projecting on my screen behind me, and I was drawing with making a hand and eye coordination so I can see what I was drawing, not in front of me, but projected on the wall. And I 30 years ago, I did a teach at Caltech, and I was drawing and made actually symbols for inductors and capacitors, just like nowadays, and picked them up and put together a circuit. So I enjoyed now this ability to really, use all the tools. And nothing for me, this is so important, because as you saw my lecture today, I emphasized using this, which I couldn't do last time because I didn't want to spend a lot of time doing it. But today I want to show you another way, effective way to teach. You show things for a first principle. And when you see me drawing, it's not like you fall asleep looking at my PowerPoint presentation. You see me doing things and changing, and then as I'm doing it, you see the thoughts, line of thoughts I came. I can tell you one thing: go out any place and put out. Look on YouTube. You can just put a transformer. You'll get hundreds of lectures on how the transformer works, and you will be disappointed how some teachers will start teaching about transformer, not really understanding it, and then going from a first principle of a Faraday transformer, but it was not really transformers, and then trying to explain how a transformer works and mix everything into it. There is no clear line of thought. It's a different. It took what I sometimes say. What is invention? When I was claiming Faraday was father of the modern Christian magnetism, because he showed there is electric fields and then magnetic fields, and And Maxwell confirmed that and adopted this theory of so on. But still, you know, the problem is that what is invention? Is invention like Nobel Prize winners in physics invent laws? You're supposed not to patent the laws. What are engineers? Why the Tesla, who invented something which doesn't exist in the world? You know what I'm saying? We couldn't say, okay, you know, just go, and it is a engineering achievement. It is a really invention to create something we didn't exist before. You know, when everybody says, including Faraday, who didn't ever wanted to accept AC, even though he invented inductors and capacitors, that they didn't, until Tesla didn't accept the transformer, and everybody was saying, we need to do DC, and we need to do direct current and direct voltage. Alternating is useless. And he said, yeah, one alternate current is useless, but two alternate currents are great, and three alternate currents are even better. You know, and this is a contraption that didn't exist before. Isn't that invention? Isn't that how you say? But that's engineering. That's not proving a law of physics and so on. But this is engineering which created, you know, the way that we transfer power. The same thing I looked at. I was in nuclear engineering for a number of years, and I studied in Belgrade the second, third, and fourth year. I was actually specializing in nuclear sciences, in nuclear engineering and control system. And I was at I went to Hiroshima and Nagasaki and visited their thing. When I saw, you know, you didn't have a nuclear fission bomb. You couldn't make it. You know, it's not something you go in nature and you dig out ore raw and make it up. No, you have to dig out uranium-235. You have to enrich it, and 1% of the uranium-235 is available. You have to purify it. You made a contraption. Then you have a radioactive. Then you have the chain reaction. All that. This is a human invention. It doesn't exist there. But look at what tremendous losses it generated, right? Tremendous destruction. 200,000 people instantly, another killed with radiation, another 4 or 5 years later, 500,000 people, you know. And I looked at that bomb. It was about this wide, the the torpedo, and inside there was a soccer bomb with the enriched uranium. Soccer bomb, literally soccer bomb, and around the rest was a regular explosive, you know, like TNT, you know, most effective to get subcritical mass and so on. So these are this always tell me, you know, people tell me about artificial intelligence, but natural intelligence. I said, look, artificial intelligence is just a hammer and nails, you know. The human intelligence is way out better, especially when we get the tools. We use artificial intelligence as a tool, you know, computers and things like that. But what as I said earlier, what human intelligence creates is unlimited. It's and the thing is, what I feel is we are now blessed that we don't live like, unfortunately, Maxwell died at 47 years old, and I always claim what he could have developed and done if he lived another 40 years like Tesla. He was died at 47 and you know, came up with the 22 second-order partial differential equations which changed the world, you know, and what he could have done if he lived longer. So that's, and we are lucky now that the longer you live, the longer chances are you can produce. My own feeling is that my production of coming up with new things is accelerated tremendously because of all the tools that I have, but also because I've been so long into it that you build, you know, your own understanding that didn't exist before, you know, and that's beauty. That's the beauty of life, that it can always be done better. That's what I'm saying. Never say never, you know, never say that it's done, you know, like when I was young And then everybody said, oh, the very true converter, there is nothing else. No, there will be many more, okay? And I hope that my lectures will stimulate some of you to come up even with the better mousetraps than I can, right? So let's keep it together, okay? And very good. So Manuel, where are you? Are you in Mexico or where are you situated?
I'm in New Jersey. New Jersey.
Oh, New Jersey. Okay.
Yeah,
all right.
right down the street from Princeton, actually, 10 minutes away from Joseph Henry's house.
Really? My daughter went 4 years to Princeton, and I visited her every year. It's a beautiful town. It's a city. It is actually school is really the town. What I understand, you know, you step out of the campus, and you are now in a city, but everything is really the campus is beautiful. Really, it's,
yeah. Cherry blossoms are blossoming, and there's Albert Einstein's Valley Way. You know, the area where he lived and everything.
He lived there in this. Was hired by them last 10 years or so. He was in Princeton University in that, Even, you know what, President Wilson, you know, he was Woodrow Wilson. He was president of the Princeton at the time.
Yeah.
Before he became...
William Shockley's house is down the street from me.
Okay. Yeah, that's a nice place to get education. A little bit expensive, you know. I know I had to pay for it, you know, but it's a nice. You know, I like always American system. This is a much better than we had in Europe. American system have this system of campuses, and when you are a teenager and growing up, what a better life than live in your classmates and have your own 4 years. Separated from this ugly world outside, you know, right? You know,
So that's you involved,
It's they're having campus is a beautiful way, and hopefully they'll keep it up, you know, even with this online. My daughter is actually teaching at Boulder, Colorado. After she was professor at Berkeley, she's teaching at Boulder, Colorado, and she's teaching actually first online. And then students get to select to come to the live lectures and online. But eventually, they ended up all online. You know, there was no. So right now,
are they back on campus now, or are they doing virtual?
She's on campus, but you know, they still have a research lab, so they take care of the. She's vaccinated like most of these professors, and so they are gradually getting to. Say smaller classes, they are doing in person, in class, but large classes they're still doing online. You know, that's. But it will change. I think prediction is that the whole United States will be vaccinated by May and June, and by the end of summer, this will be over. And some people say they'll kind of naturally die. Like a Spanish flu, you know, maybe then 100 years from now we may experience the same thing, but now we're okay, you know. That's tradition. But yeah, that's great. So we even have some Americans that attending this course, right? You know, so that's good, very good. Just spread the word, get your friends, and so hope to see you all in. May 3rd, which is Monday, and we go for 6 weeks and enjoy this sharing. And as I said, bring your friends and girlfriends and brothers and sisters, and so on. Okay. All right.
Thank you so much, Dr. Cook.
Thank you very much.
And happy birthday to the Cook Converter.
Oh, hey, you know that. You know,
I was the one that wrote the comment on the electronics group.
Studied that. now you can find where the blame is. So that was quite ingenious. I was supposed to say because you sent the post and it said happy birthday to Chukwuemeka, and when I say happy birthday, And Chuk, I thought it was this not my birthday time, but then, yes, but you know what? It was such a long time that I forgot. It was, it was not kidding. It was April 1st. It was almost sounding like, April is like April 1st is to make a jokes, right? And my invention of Chuk converter happens April 1st. And I'll tell you, as a parting shot for this, how it happened. It was Friday afternoon. I had from 2 o'clock to 5 o'clock in the evening. After my second year at Caltech, I had a PhD qualifying oral exam. And Professor Middlebrook was my advisor, and I passed it. And then next day, first thing in the morning, I had a soccer accident and broke my meniscus. And then I signed up. I said, look, I'm going to, after my PhD exam, oral, I'll go to, I signed up to go to hospital, and they got the surgery on Saturday morning. And then Saturday afternoon, I called Professor Middlebrook from my surgery room and said, Dr. Middlebrook, I am here in the hospital. He said, what? He thought I got a, nervous breakdown somehow after PhD exam. Then I explained him, no, I get this problem with the meniscus was taken out, so I won't be able to come to Caltech for 2 weeks because I can't drive, Oh, that's okay. So there was Saturday, and then Sunday when I was at home, and actually, I don't know, I'll have to check. What is it? You can check too. April 1st, 1975. Might have been Sunday or it might have been Monday, because I remember, and most likely be Monday, because my wife is electrical engineer from Serbia, Yugoslavia then. She was working at Hughes Aircraft, and I was during the day, didn't have nothing to do, and I kind of played, and I came up with a Chuk converter, right? And then she comes back from work, and I said, look what she's an electrical engineer, right? I mean, my classmate, they're like a year younger. And I draw the circuit, and she, could you explain how this works? I said, no problem. Turn transistor off, dye turns on, turn transistor off, this will, and then this is a converter. So then I said, oh, she understood it, then well, maybe that must be something which is good, So then after that, I have actually came up with closely to that with a couple inductor converters. And then I pretty soon coupled two inductors together on one common core. And then I realized I don't need the rest of the converter. All I need to do is drive the two windings in parallel, drive them in the square little voltage source and see where the current goes. So I started analyzing this circuit, and then she was pretty good in that things. And I said, this is this magnetic circuit, this is model, and this is how now the ripple currents will go. And she looked at it and said, yeah, there's no reason why I shouldn't. So I went back to Caltech next day and built it in a laboratory. And just as I was making break in laboratory, they proved it. And I showed the circuit to Professor Middlebrook, but showed him before I built it. And I said, this is how it's going to work. This is okay, like comes in one area and comes out in the other, right? But then that day when I verified it, then I went to Colorado Boulevard in Pasadena, and I went to some rather nice, interesting Chinese restaurant. I went there for a lunch. So I went to a Chinese restaurant, and here it is. I come into it, here's Middlebrook with his wife having a lunch, okay? So I said, oh, Professor Middlebrook, remember the converter that I showed you? It works. I said, okay. So that's how I proved it. And a couple of weeks later, I come to him and said, Dave, I will put these two together on the magnetic core together. And he was experienced professor and, matched my senior. I said, you can't do that. These inductors, how you can operate it as a transformer, So he was doubtful that you can do that, And then I concocted this thing that I put it on a common core, but then I use a air gap to change the coupling between the two windings, and then magic happened. the ripple current on one output inductor went to 0 and through 0 to negative. That's my zero ripple true converter, okay? Talking by that, okay? I have another news for you. Now I have a zero ripple, but without coupled inductor and without two converters. I showed you one today with the Chukbak 2, the two converters in parallel had zero ripple on the output. We couple inductor, input and output inductor coupled, and I send the ripple from output to input and I get zero ripple. And now I don't need that. I have a single converter with zero ripple. Stay tuned, okay?
Well, thank you. That's a beautiful gift.
Yeah. Okay, all right. And make sure it's all recorded, I hope. All right, okay. So thanks a million for your attention, and you are, I appreciate all these discussions, and let's move on. I will not be doing any more of these webinars, but I'll be preparing for starting this 6 weeks course on Monday, 3rd of May, and it'll probably last, 6 weeks from there. So we'll have a lot of fun doing it, okay? And last but not least, let's have this. Thank you very much.
Thank you very much.
Take care, Dr. Cook. Thank you very much. Excellent.
Oh, Jose, thanks for coming from Philippines all the way to Southern California, right? Jose is in Philippines. What's the Philippine time difference? I think it is maybe, I don't even know which way. I know Hawaii, and then it's further than Hawaii, right? You know, that's Philippines. It's, wait a minute, Philippines is, wait a minute, isn't that where Indonesia is, and then Philippines and that stuff, right? Do you want to? I'm trying to position, where is the Philippines? Is
Maybe 5-6 hours from Sarajevo and Belgrade, maybe.
how many? 6
Maybe
hours forward?
6 hours from Belgrade.
Oh, forward. Forward.
Yes, yes, I don't know.
Oh, okay. If it is forward in Belgrade, Sarajevo is 9 hours from my time, and plus 6 hours, there must be 15 hours, right?
Now I checked. Now the time in Philippines is 2:30. 2:30.
Last part 2:30 in
2:30 is now is Philippines. 2:30.
2:30 in the afternoon or in the morning?
In the morning after midnight.
Jesus Christ, Jose, thanks very much coming at 2:30 in the morning in the Philippines. What a sacrifice. Let's go. That's calling enthusiast, right? Okay. All right. At least I now know I can give a lecture to Philippines. Okay. New Zealand is 4 in the morning, and he's 2:30 in the morning. New Zealand is further out. New Zealand and Australia are like 3-4 o'clock in the morning. But you know, South America is only 3 to 4 hours difference from 8 o'clock. Here is the noon time in most of the South America. That's not bad. India is also. Here is in India, Arun Kumar. Are you from India or you are in? I know Bhaskar, you are in Austria, right? Arun, where are you? You are in India. Bhaskar, you are 9 hours difference, right?
Yeah.
No big deal. Arun Kumar sounds suggesting it's from India, right? And India is 11 hours late. So here is 7 in the evening. So 7, 8 in the evening in India. 4 hours. I had a lot of time from my close people from Ukraine, from Cyprus, and Russia, 10 hours, 12 hours, you know, at least the western part of Russia. Okay, some interesting short form, KL. Rainer has come down. I used to have a lot of, out of my 36 PhD students, I used to have 34 were American, 34 were foreigners, and only 2 were American. My first PhD student was American, and my last PhD student was also American. All the others were from all over the world. Okay, and I can, yeah, I see you, but and I see you speak, but there is a lot of noise. Microphone working or?
Not really.
Okay, and I see one of all right, okay, John Berlin Barland. Oh, this is interesting. I see here a list who are participants, but I see, you know, interesting. I see on this gallery view, Velimir, are you there? I don't see you on this listed, but I see you on gallery view. No, Velimir. He's from Croatia, Zagreb, my hometown when I was born. But it is, it's interesting. The gallery view shows a name and but muted microphone, muted video, but it is not on the list which are connected. So that's interesting. So far, actually, technically, it works very well. I think videos are good, right? The audio is good. I used to have this thing here, but not really needed because my 43 inches monitor has a built-in nice stereo speaker, so I hear it very well, and that's one thing. That's good, and video quality is good, and hopefully the recording will be just as good because we had this thing here. So more and more people are learning how to utilize this video, and I put it in my note. If you or your friends have problem connecting with audio and video, everybody has now cell phone, and cell phone have a built-in camera which is second to none, and it has good audio and good video. So if you have a problem or your friends have problem, don't have a computer, they don't need to. They can use a cell phone and use it actually in a landscape format, or even for portrait format, but landscape is more closer to what we see on the screen. So that's good. Okay, and so that's the thing. All right, and oh, you know what? Let me do one thing. That's one more thing I want to do. You remember famous word from Steve Jobs? One more thing, and one more thing is I want to play for you my favorite music, and my favorite music is what I call it In October 15, I had a special bonus lecture for my first online class. In that online class, I played them my favorite music, which I claim, and I defined October 15 to be Tesla Day, to celebrate every year Tesla Day. I just defined it that way. And then that also I defined it as this music song as an anthem of power electronics. You know, anthem, like every state, every country has its own anthem. And I call this anthem of power electronics worldwide people. Hopefully, worldwide people will unite just like this. So I think here, let me get, oh, I have a chat on, I didn't link on the chat. I had 17 people on the chat. Wow. I congratulate Eskandari to everybody. Thanks from Iran. So here's a guy from Iran. So we are talking here. Oh, Rene, that's the only woman today. That's cool. That's cool. Okay. Can you put it? Oh, it's okay. You can put it on a cell phone, right? So you can put a cell phone on a portrait. You know. Yeah, exactly. You see that? Now you have a little bit score, but it's okay. Reinek, say something. Let me put you in a view and say something in English from your. You're in Tehran or where? Where are you? Where are you from?
No, I'm from Tabriz, not Tehran.
It's okay. This reminds me, I had my 36 PhD students, one of my first PhD students, you know, I know all these foreign students' names. Farhad Barzegan. He was from Tehran University, and he's like all my classmates in Belgrade University. We walk on water. We could do anything, electrical engineering, computer science, control system, and he was capable of all of those. He was one of my star students very early. The first 5-10 students, he was from Tehran. In fact, he wrote my very first program, which is called Teaching Converse Analysis and Measurement Program, which was done, you know, with the drawings and so on. And he put that program, and we actually provided it from our conference, our supporters, supporting. Are you doing electronics study or what?
Yes, I have graduated with master degree, and I'm planning on studying for a PhD.
Oh, you're going to go for a PhD. Okay. All right. Get to my course, and you'll get a PhD from me before you get a PhD from Tabriz. Okay.
I hope. Thank you.
All right. Okay. I had also some people from the Iran in the past, but time difference. Now, what is your time now? Now your time must be like 3 o'clock in the morning.
No, it's night, 11 p.m.
Oh, 11. It's easy. So just go. And actually, when we started now, it's what? Now it's 12 o'clock. So we already overshoot 2 hours. But so now it is 11 o'clock, and my time is 12. So it's 11 time delay, right? In Europe, 9 hours, but in Iran is 11 hours. So, okay, so it's not that this is extended time discussion. You didn't have to be on it, but 8 to 10 in the morning, that is, 7 to 9 in the evening, right? So that's
yes. 11 and half hours.
So
exactly.
So for the actual course, when I'll be doing 8 to 10 in the morning and hopefully half an hour discussion, it will be not bad. It's 7 to 9 in the evening your time. Okay. And you know what? You're a professor, and a couple of more of your students, graduate students, to my course, and we'll have a fun. Okay. Maybe they will. And I don't know if you're aware of, but I actually said that most of these professors would bring 2 of their best graduate students, and they pay for their course, and then you all get half a 50% discount for having 3 or more people. So and make it discussion, educational. I'd like to learn what you're studying, and maybe you will get some from my course. You'll get a lot of ideas because there are a lot of things which are not completed. That can get some idea how to, maybe turned out to another PhD student of you and a couple of your other colleagues, students. So
yes, but unfortunately, sorry to say this, but the Iran money has dropped. Money value has dropped really significantly in recent years, and due to sanction, we cannot have any money transaction.
One question. You are, I used to have quite many female students in my classes, but how is the situation in Iran? A lot of graduate students in power electronics are women, or just a exception to the rule, right? Understand?
Right. I lost them. I didn't understand.
Oh, I see. I was saying female students, male and female. You have
yes.
Do you have other ladies who are studying power electronics?
Yes. One of my friends now is doing her PhD in the USA, and yes, we have many females doing power electronics.
So one of your friends who is a lady, she's studying in the United States already.
Yes, for PhD. We were classmates in the master, and now she's doing her PhD.
Where she's doing her PhD? In the United States?
In I think Brooklyn University.
Berkeley, UC Berkeley. Right. Yeah, that's cool.
Yes.
Yes.
We have many Iranians studying the PhD in other countries.
Okay. Tell all of them that what they are missing, because we need more ladies like you.
I will.
Right now,
I will.
You're the only lady, so we need more ladies, okay?
Yes. Okay.
What I share one thing with you. I will. I have 3 beautiful daughters, and I'm glad I have daughters, because when the people ask me why didn't you go for a 4th child to have a boy, because any men who want to be macho men, they need to have a boy, right? And I told them I have 3 perfect girls, and I don't want to spoil my perfect record. They're all smart, beautiful. So if I were to get a boyfriend, maybe it won't turn out as good. So then I didn't want to take a risk. Okay, so that's right. And even my hero Nikola Tesla was said to he wasn't married and he didn't have children, but he was saying that women are smarter than men, and that will happen one day, that they'll show that they are smarter than men. So we are on the way of that way probably already. So so thanks for attending all the way from Iran. So that's great. This is really the whole world, and
it's a great opportunity. Thank you for providing it.
Yeah, and let me now try to on my computer. I will do one thing just to have a nice, discussions. So I will put my favorite song on it. Let me just give me a second to find it. So ladies home. Let's see, YouTube. Okay. Okay.
If you're an accredited investor, I have something I consider a big.
Can you hear it?
Yes.
I hope you can see it also. Do you see?
No.
No. How about now?
Yes.
See?
Somewhere will soon make a change. We all a part of God's great big family.
Oh, yes. We are the world.
And the truth.
In Africa,
Love
I can
is
let
all we
you 40 other people.
We are the children. We are the ones who make a brighter day. So let's start giving. There's a choice we're making. We're saving our own lives. It's true, we make a better day. Just you and me. Well, send them your heart so they know that someone cares, and their lives will be stronger and free. As God has shown us by turning stone to bread, and so we all must lend a helping hand. We are the world. We are the children. We are the ones to make a brighter day. So let's start giving. Oh, there's a choice we're making. We're saving our lives. It's true, we make a better day. Just you and me. We're down and out, and there seems no hope at all. But we just believe there's nowhere we can fall. Let's realize that a change can only come when we stand together as one. We are the children. We are the ones who make a brighter day. So let's start giving. There's no choice we're making. We're saving our own lives. So make a better day, just you and me. We are the world. We are the children. We are the ones who make a brighter day. So let's start giving. There's a choice we're making. We're saving our own lives. It's true, we make a better day. Just you and me. We are the world. We are the children. Our children. We are the ones who make a brighter day. So let's start giving.
Hey, boy,
It's true, we make a better day. Just you and me. All right, let me hear you. We are
$8.
We're saving our lives. It's true, we make a brighter day. It's just you and me. Come on now, let me hear you. We are the world. We are the world. We are the children. We are the children. We are the ones who make a brighter day. So let's start giving. So let's start giving. There's a choice we're making. We're saving our lives. It's true, we make a better day. Just you and me. Yeah. We are the world. We are the world. We are the children. We are the ones who make a better day. So let's start giving. So let's start giving. There's a choice we're making. Yeah, we're saving our lives. It's true, we'll make a better day. It's you and me. We are the world. We are the world. We are the children. Yes, sir. We are the ones that make a brighter day. So let's start giving. There's a choice we're making. We're saving our own lives. It's true, we make a better day. Just you and me. That guy. All right, did you hear what I said? There's a choice we're making. We're saving our lives.
Thank you.
Thank you.
That's great.
Thank you very much. Noontime. Time to do something else. Okay. See you soon.
This rad VCR is your solution. It's
And
available.
in English, it goes, see you later, alligators, or see you in a while, crocodile.
VHS tape onto DVDs. This makes it very easy to do that. If you want to try to get one of these,
Bye.
it would cost you around $700 to $1,200.
Thank you very much. Goodbye.
Thank you very much. Bye.
Bye.
Bye. Bye.
Thank you, Marion. Enjoy the rest of the weekend, and hopefully you enjoy the lectures and discussions. Okay?
We are looking forward.
Thank you. Thank you.